So in this problem, we're given this large number n, which is 2 to the power of 48 minus 1. So when you see such large expressions, clearly we don't have to compute this. So we have to look for some way of rewriting this expression so that it's easy to see what the factors of n are, or what numbers it's divisible. And one of the important ones that they use is the difference of squares identity. So x squared minus y squared, which is x plus y times x minus y. And the key is to notice this pattern here, because it's really 2 to the 24 square minus 1 square. So that is your x, this is your y. So we can write this as 2 to the 24 minus 1 times 2 to the 24 plus 1. Now we can apply the identity again to this piece. We can't do it to this because that's plus 1, so it doesn't follow that format. So this would then become 2 to the 12 minus 1, 2 to the 12 plus 1. And we can keep doing this, at least to this portion. So that's 2 to the 6 minus 1, 2 to the 6 plus 1. And at some point you have to compute these when the numbers become small. We can take this one step further, 2 cubed minus 1, 2 cubed plus 1. And so we won't worry about these large terms here. So let's compute this. 2 cubed is 8. So that is 7. And this would be 9. And we can actually compute that too. 2 to the cube is 8. 2 to the 4 is 16. 5 is 32. 2 to the 6 is 64. So that becomes 65. And then we have these other numbers. Questions: which of the following is a factor of that number? So 5 is, because 65 has a 5 in it. 7 also, divisible. I have a multiple here. And then 13 actually divides 65, because 13 times 5 is 65. So the answer is all three are factors of n, or n is divisible by all three. So the answer is E.